So let's try to discuss some past wave equations given from linear motion section, linear motion equation section. Normally past wave equations are given, essay equations are given with the paragraph. There will be a certain paragraph, small description will be there. A paragraph means with the 5-6 lines. Under that they will ask about 10 to 12 questions. How many questions normally asked? 10 to 12 questions saying Roman number 1, Roman number 2, Roman number 3 and so on, right? So now we will be able to answer some of the questions but not all, right? So please write this question was given in, I'll give you the printed tunes but today let's write it. 2002 AL first essay question. 2002 AL first essay question, right? 2002 AL first essay question, right? In this question, write the heading as 2002 AL first essay question. In this question, look at board here. They have given us a figure. They have given us a figure. Stop writing. Just look at board. A boy runs from C to D. They have named this CD as a platform. What is the name of they have given? Platform. It means a horizontal path. A boy runs on this horizontal path with a constant acceleration. A boy runs along this horizontal path with a constant acceleration. So initial velocity should be found, right? And he leaves this platform with the horizontal velocity. Finally, he jumps to water. Some water is there below. So we can't answer that part now because we know only the linear motion equations. It tells me a student of mass, don't write, no need write because I'll give you printed figures. A student of mass 50 kilogram accelerates uniformly from rest at one end C of the platform to the other end capital D and leaves the platform with, in the horizontal direction with a speed of 5 meters per second. Speed along a straight line path is a velocity, right? Speed along a straight line path is a velocity. It means final velocity is 5 meters per second. He starts, the length of the platform is 5 meters. So what is the displacement here? 5 meters, right? The time taken not given. What about the acceleration? A student starts run at rest. What does it mean here? A student starts run at rest. It means what is the initial velocity? 0. Initial velocity is 0. So those are the given details, right? So Roman number 1 asks calculate the acceleration. What's the first thing? Find in the, don't write, find in the acceleration. Roman number 2 asks how long does he take to reach to the other end? It means first question asks us to find the acceleration. Roman number 2 asks us to find the time taken. Roman number 3, to answer Roman number 3, you have to learn physics further. You have to wait some more time. You have to learn mechanics more to answer Roman number 3 and 4. There are questions up to Roman number 10. Okay, dear? Out of 10 questions, now we can answer 2. The first 2 questions are okay for us. Okay, and we are going to use these equations to answer this part of the questions. We have all written these equations saying a summary. Therefore, no need to write these equations. No need to write these equations. Write the heading 2002 AL first essay equation. Draw this figure. For the Roman number 1, find acceleration. For the Roman number 2, find time. You can do it alone. You don't want my help. Do it without my help. Try it. Right, I think time is enough, and many of you have sent me the answers. All the students can send the answers to my Zoom chat so I can check whether you have put the correct answer or not. Right. We want to find the acceleration. We know the initial velocity, we know the final velocity, we know the displacement, but we don't know the time. If we don't know the time, we should not use the equations with time. Okay, dear? If we don't know the time, we should not use the equations with time. It means we should not use the first equation, we should not use the second equation, we should not use the third equation, because in all 1, 2, 3 equations, t is there. Okay, dear? Therefore, we should not use any of the first 3 equations. We should select an equation without the term t, without time. Okay, dear? The only equation without time is the fourth equation, that is v square equals u square plus 2as. Okay? Final velocity is 5, initial velocity is 0, plus 2, acceleration is the thing that we want to find, the displacement is given as 5. So this is how we get the answer for Roman number 1. Square of 5 is 25, 0 square is 0, 2 times 5 is 10, 10e. Am I right here? So you get 25 equals 10 times e. 25 equals 10 times e. So then what is a here? If this is actually multiplication 10, this is actually multiplication 10. Multiplication 10 comes to the other side as division 10. 25 divided by 10 is 2.5, but don't write 2.5 equal a. It's a very ugly way of keeping an answer. Always write, therefore, a equals 2.5. Do not forget to write the units. Who got this answer? That's it. Right, then how do we find the time taken for the motion? Please believe me, the best equation to find the time is v equal u plus a. What's the best equation that can be used to find the time here? V equals u plus a. So use that equation and try to find the time, that's it. We have found acceleration as 2.5 meter per square seconds, right? We want to find the time taken for the motion. So I apply the equation v equals u plus a. Final velocity 5, initial velocity 0, acceleration is 2.5 into t. It means 5 equals 2.5 times t. I'll take 2.5 to this side. 5 divided by 2.5 equals t. So therefore, t equals 5 divided by 2.5. Therefore, the time taken for the motion is 2 seconds. So this is the answer for Roman number 2. For the mechanics first essay question 2002 A-level paper, we can answer only the first 2 questions. We have to wait some more time to answer the other parts of the question. Complete. Then let's try another past paper question. We cannot answer everything, but let's try to do the things that we are able to do. Even we can't do all the things, even we can't answer all the questions asked in the paper. Let's try to do the possible things. This question was given me. Don't worry, I will not erase anything else. I just erase these parts to draw a figure. Right. This question was given in 1997. Before your birth, right? This question was given in 1997 AL paper. First essay question. First essay question. Write the heading. Here it is said, listen to me dear. Listen to me, this. A 70 kg sprinter. Sprinter means unmarried young person who runs. No need. This is not English literature class. It's a man. He is a man. A 70 kg man running a race of 100 meters. How many meters dear? 100 meters. Pushes on the starting blocks. Have you seen that they are on some starting blocks and they push and jump? When they start, actually there's a jump when they are starting a run. Have you seen that kind of things? Just searching YouTube's, right? But we don't want that kind of thing. There is a game. He wants to run a 100 meter. He leaves the blocks with a speed of 5 meters per second. So what is the initial velocity of this man here? 5 meters per second, right? He then accelerates for a further 5 seconds. So that his speed becomes 12 meters per second. What is the initial velocity of this man? 5 meters per second. Right? It is impossible for this to be an ordinary person. Just after 5 seconds, his velocity becomes 12 meters per second. That's what I said. 12 meters per second, right? And continues with that speed until the finish line. So what is his velocity when he finishes the game there? 12 meters per second. Okay, so we can identify two special regions. A is the starting point. And at the point B, velocity increases to 12. B to C, he travels with the constant velocity of 12 meters per second. Okay, dear? No need to write these descriptions, details, because I'll give you a printed tube. In that tube, these questions are included. Therefore, no need to write them. Just write the heading and draw the figure. Just write the heading and draw the figure. After that, we will try to answer the questions that we are able to answer. Right. For this question, we cannot answer Roman number 1. Roman number 1 is based on impulse equation. Have we learned something so called impulse? No. Therefore, Roman number 1 still we can't. Right? Recently, you will be able to answer Roman number 1. Don't worry. Let's do the things that we are able to do. We should not worry about the things that we can't do. In near future, I'll teach you impulse after Newton's laws of motion. Just after Newton's laws of motion, we can learn impulse. Have you learned impulse in O levels? Anybody in the class? No. So forget it. Right. Roman number 2 is very simple. Roman number 2 asks us to find the distance traveled during the acceleration period. It means S1. And we want to find T1. We should find S2 and T2. So those are the things that we want to find. What are things we want to find here? T1, T2, S1, S2. Roman number 2 asks us to find S1. Please mark them all. For the Roman number 1, put a question mark and leave. Or for the Roman number 1, just write impulse and leave it. For the Roman number 2, you can do it. You can find, you can find S1, but clearly there's a very important fact. Stop writing. Stop writing. It's a very important thing in the examination. There are 2 different cases in the motion. What are the 2 different things there? A to B motion and B to C motion. So whenever you apply an equation, you must indicate whether you apply the equation from A to B or B to C. Otherwise, no marks. Especially in school term test, no marks. So therefore, clearly indicate we want to find S1. So clearly indicate you apply the equation from A to B. Then select a suitable equation, apply it, and find S1 to it. That is Roman number 2. What is the best equation that can be used to find S1 data? Or how did I give you enough data for the question? Initial velocity given, final velocity given. Check. Let me check. Time is given. Sorry. T1 is given in the question as 5 seconds. He accelerates further 5 seconds so that his speed becomes 12. Speed along a straight line is a velocity. Velocity. T1 is given. I'm so sorry. The time is given as 5 seconds. Now try it. T1 is given as 5 seconds. Now select a suitable equation and find the displacement S1 and also find the acceleration also. Acceleration is not asked, but try to find displacement and acceleration both. we can easily find the displacement by using the equation. What's the equation? We know initial velocity, final velocity and time. So let me find the acceleration first. What am I going to do here? Let me find the acceleration first by using the equation v equals u plus at. Final velocity 12, initial velocity 5, acceleration I don't know, time is 5 seconds. 12 plus 5 come to this side as minus 5 equals a times 5. 12 minus 5 is 7. This is a into 5. Take 5 to this side. 7 divided by 5 equals a. We never leave an answer like this. We never leave a number equals a symbol. We always write a symbol equals number. So what is a then? A equal 7 over 5 meter per square seconds. If I divide 7 by 5, I get 7 divided by 5 is 1, 2 remaining. 20 divided by 5 is 4, 1.4 meter per square seconds. Who found this acceleration earlier? After that, apply S equal ut plus half at square equation. Then you can find the displacement. So what is the displacement? To find the displacement, then we should apply the equation S equals ut plus half at square. Right? Clearly we should say we apply this equation from A to B because there are two sections, A B section and B C section. A to B displacement is 1, initial velocity is 5, time taken is also 5. Plus half, acceleration if you want you can use 1.4. Let's say you have used 1.4. The time is given as 5 and square of that. Then S1 equals 5 times 5 25 plus 1.4 divided by 2. 1 divided by 2 0. 14 divided by 2 7. Square of 5 is 25. So S1 equals 25 plus 7 times 5 35. Am I right here? 7 times 5 35. 7 times 2 14 with the remaining 3 17. We should remove one decimal point because of 0.7. So 17.5. If we add them, we will get S1 equals 5, 7 plus 5 12, 1 remaining, 1 plus 2 3 with the remaining 1 4. 42.5 meter is the displacement from A to B. Who got this answer? Complete. So mechanics is a very good lesson for you to learn some O-level maths. The mathematical simplification, adding, subtraction, multiplication. It's good for if a student is there who is weak for maths. This is a very good lesson for him or her to learn maths. Okay. But there is another method to find the displacement without finding the acceleration. I found this acceleration because next thing we for the next question we want acceleration. That's why I have found the acceleration. But there's another equation you can use it to find the displacement without finding the acceleration. What is it here? We can use S over T equals U plus V over 2, which is known as the average velocity equation. What is that? What is the name of the equation here? Average velocity equation. So please write second method. Second method. Underline it. And write the average velocity equation. S over T equals U plus V over 2. We apply this equation A to B. We apply this equation A to B. A to B displacement is 1 time T1. Actually time is 5. No need to write T1. Velocity at A is 5. Velocity at B is 12 divided by 2. Please use this equation and check whether you get the same answer as 42.5 meters. Check there. Right, then what will happen? S1 over 5. This is 5, eh? Can you see my 5 as 5? 5 plus 12 is 17 divided by 2. Division 5 goes to the other side as lamai. Division 5 goes to the other side as multiplication 5. So S1 equals 5 into 17 divided by 2. S1 equals 5 times 7, 35. 5 times 1, 5 with the remaining 3, 8. 85. 85 divided by 2 is nothing. 85 divided by 2 is 42.5 meters. So we got the same answer even from the average velocity equation. This is the most beautiful thing in science. This is the most beautiful thing in science. Whatever the method you use, you always get the same answer. It means different methods will not give you different answers. That's the beauty of science. Write this method also. So we were able to answer only Roman number 2. We cannot answer Roman number 1 because we don't know the impulse equation and we don't know what the impulse is. That's the truth. We have answered Roman number 2. Roman number 3 can also be answered. Sometimes you may have forgotten. What is work done here? O level. What is work done? What's the equation that we use to find work done? Force into displacement. Roman number 3 asks how much work is done by this man when he runs from A to B. What is Roman number 3 dear? How much work is done by this man when he runs from A to B? And they have used a word mechanical work. Can this man do some electrical work? When he is running, mechanical work, right? So then we know the acceleration, mass of this man given as 70. Then to find the work done, we want to find force. How do we find force? What is the equation that we normally use to find a force in O levels? F equals ma. Whose equation? Newton's second law of motion. But we teach Newton's laws of motion again in advanced level, because O level version of Newton's laws of motion is not enough for the advanced level questions. Okay dear? So Newton's laws of motion again in our advanced level syllabus, we have to teach it to the correct level. O level is not, it's not a level, it's not enough. You will understand when you will realize it when I start teaching Newton's laws, right? Now I just use the equation. Look at board. I'm going to answer the Roman number 3. I can apply F equals ma. Please don't write. Now please don't write. The mass of the man is given as 70 kilogram. Acceleration 1.4. How do we simplify this thing? There are two methods to simplify. One of the method is directly multiply. You can directly multiply. The second method is this way. I would like if you follow the second method. 1.4 can be written as 14 divided by 10. Am I right? 1.4 can be written as this acceleration, right? 1.4, 7 divided by 5 is 1.4. If you want, you can write 1.4 as 14 divided by 10. So what is the advantage of writing 1.4 as 14 divided by 10? Cancel it out. We can easily cancel out this 0 and this 0. After that, we just want to multiply 7 by 14. How to do it? 7 times 4? Very difficult. 28. 7 times 1? 7. With the remaining 2 of 22? 28? 98 Newton. Roman number 3 asks us to find the work done by this man when he was running from A to B. To find work done, we want to find the force. I have applied O-level equation F equals ma to find the force. Do it. Write them all. Right, then how do we find the work done? If we know the force, if we know the displacement, can't we find the work done here? Can or can't? So for the Roman number 3, it is asked us to find the work done. It is asked us to find the work done. How do we find work done? Work done equals force into lamai displacement. Force is 98 Newton. You can correct the mistakes like this. Displacement is A to B displacement S1. S1 is 42.5. Now prove me that you know how to multiply. Prove me, please, that you know how to multiply. Multiply and tell me the value. $98 multiplied by 42.5. Do you know that? How much? Liger, do you know maths? So you see, those days before 2000, actually huge multiplications were there. This is 4165. 4165. 4165 joules or Newton meter. Same. Joules and Newton meter are same. The next part of the question. Next part of the question means Roman number 4. Find the time taken by this idiot to complete the race. Find the time taken by the sprinter to complete the race. Now look at both A to B. He runs with an acceleration. A to B, the person runs with an acceleration. A to B displacement 42.5 meters. What is the total distance that the person should run? 100 meters. Am I right? The game is to run a distance of 100 meters. So therefore, S1 plus S2 should equal to 100 meters. So S1 is 42.5, S2 is unknown, this is 100. So therefore S2 equals 100 plus 42.5 comes to the other side as minus 42.5. Please subtract and tell me the value. Please prove me that you have learned O-level maths from a good teacher? Subtract and tell me. Finished? Let me see whether our students know O-level maths. My hand is good. Voice. Lovely. Is it clear? For me, normally I don't subtract, I normally add. 42.5 plus 7.5 is 50. 50 plus 50 is 100. Therefore, answer should be 50 plus 7.5, 57.5. Who got this answer? That's good. Right. Now, B to C, does he accelerate? Is there any acceleration from B to C? No acceleration. B to C, velocity is not changed. If velocity is not changed, it is said to be a constant velocity. What velocity, dear? A constant velocity. When an object is moving with a constant velocity, we can apply an equation. And you know that equation even from O-levels. A constant velocity equals, please don't write, a constant velocity equals displacement divided by time taken. Okay, dear? Right, we are going to answer for Roman number 4. I don't know whether I have written Roman number 4 here or not. Please write. There is no change, please write this sentence. There is no change in velocity from B to C. There is no change in velocity from B to C. B to C. Therefore, the man runs from B to C. The man runs from B to C with a constant velocity. Therefore, the man runs from B to C with a constant velocity. Hence, the following equation can be applied from B to C. Hence, the following equation can be applied from B to C. Hence, the following equation can be applied from B to C. What's the equation there? Please don't write. What's the equation? Velocity equals displacement divided by time taken. Velocity from B to C is 12. Displacement from B to C is S2. Time is T2. Can you do the rest and find T2 here? Do it. So 12 equals S2 57.5 divided by T2. Do you know cross multiplication? Cross multiplication means actually we can change, not multiplication. We can interchange the terms like this. Have you learned this kind of a maths in O levels? T2 can be taken to the place of 12 and 12 can be taken to the place of T2. Okay? We can interchange the terms. Please learn it from here, from this example. T2 comes to the place of 12 and 12 goes to the place of T2. So once you interchange the terms, T2 is subjected. So finally, you just want to divide 57.5 by 12. Do it. If you divide, you get an approximately 4.8. No need to divide exactly. So T2 is approximately 4.8. 4.79 means 4.8. Even in the examination, it is okay to take the T2 as 4.8 seconds. Who was able to divide? Yes. Actually, Roman number 4, it does not ask T2, it asks us to find the total time taken for this man to complete the race. So what's the total time taken for this man to complete the race here? T1 plus T2. Okay dear? So leave a line and write the total time equation. The total time taken for the man to complete the race. The total time taken for the man to complete the race. The total time taken for the man to complete the race equals T1 plus T2. T1 is 5, T2 is 4.8. Therefore, the total time taken for this man to complete the race is 9.8 seconds. Who got this answer? So that's all we can do for this paper. So like that we can improve our level. With the time we can improve our level. Do you have paper 1? I have a small question paper with some questions. Do you have it? Right. So that's all for this question. Please give me the. Initially we use some simple papers. We should start with the very simple things here, right? It means if you want to go a very long journey, you should start with simple things. Okay. Even the horse can't run just after his birth. Even he barely gets up to walk. Okay. So it takes time. So therefore, at the beginning, we give some simple questions. Online student, if you do not have this paper, please send me a WhatsApp message. Then I'll send you the PDF of the paper. If you do not have, but now you don't want the paper because I'm going to read everything. So let us try some of the questions given in this paper. Let me try. Let us answer some of the questions given in this paper. No need to use a separate book, use the same book and write. Paper 1. Question number 1. I'll read the question, please don't write it. Please don't write the question. If you don't have the paper, just send me a WhatsApp message, then I'll send you the PDF. Right? It's a very simple paper. An object starts to move at rest. Don't write. So what is the initial velocity here? Initial velocity is 0. An object starts to move at rest. It travels along a straight path with a constant acceleration for 10 seconds. Right. An object starts to move at rest. You can go along a straight line path. Starts to move at rest means initial velocity is 0. The time taken for the motion given as 10 seconds. After 10 seconds, its velocity is v. I don't know whether the velocity v is given or not. Let me read further and let me find it. The displacement of the object. The displacement of the object for 10 seconds is 60 meters. What is the displacement here? 60 meters. Displacement of the object is given as 60 meters. The question asks us to find the acceleration and the final velocity. Okay, dear? An object starts to move at rest along a straight path with a constant acceleration. The displacement of the object for 10 seconds is 60 meters. Find the final velocity and the acceleration. Write paper 1, draw the figure, try to find acceleration and the final velocity yourself. Try it. So it's so simple, right? I'm so happy all of you have got the correct answer. Online student, please send me answers to my Zoom chat. Very good, very good, excellent. Online people also very good. Right, look at board here. Time given, initial velocity given, final velocity not given. Displacement is given. If displacement is given, the best thing is starting with the displacement equation. If the displacement is given, what's the best equation that should be selected here? The displacement equation. There are two displacement equations. Let me use. You can use any displacement equation. So let me use this equation, and whenever you use an equation, please indicate the moving direction of the object on the top of the equation. Please practice it. Otherwise, your school teachers will blame you, and there will be problems. Right. So indicate the direction and write is equal ut plus half at square. Now don't write anything, just look at board. Please listen to me carefully. Please don't do anything. Displacement is 60 meter. Initial velocity 0. Time taken 10. Half, we don't know the acceleration. Half at square. T is 10 square. So 60 equals 0 into anything 0 plus half a into what is square of 10 here? 100. Very difficult, eh? 100. So 60 equals 100 divided by 2. 100 divided by 2 is 50 times a. Take 50 to this side. 60 divided by 50 equals a. We should always write a equals something, not something equals a. Look at here, a number a equals to a certain number. Right? So we can easily cancel out this 0 and this 0. Am I right? 0 and 0 can be cancelled out. Then you get a equals 6 divided by 5. Unit is meter per square seconds. Meter per square seconds. Got it? Who got this answer? For my questions, I really appreciate if you get the answer as fractions, but unfortunately in the examination you have to divide. You have to divide in the exam. So I'll also divide. 6 divided by 5 is 1. 1 remaining. 10 divided by 5 is 2. So the acceleration is 1.2 meter per square seconds. Who got this answer? Right, that's it. If you have any difficult points, you can ask me. I can help you, right? Because sometimes even this mathematical simplification may be difficult. There's a probability for this to be difficult. Yes. If so, please ask. I can help. Right, then how do we find the final velocity? What should we do to find the final velocity? Now we know the acceleration, therefore we can apply the equation v equals u plus Take. Initial velocity is 0, acceleration 1.2, time taken 60. Okay dear? Let me write 1.2 as 12 divided by 10. Can you understand this, Maxi? When you write 1.2 as 12 divided by 10, right? That 10 and 60 can easily be cancelled out. Can you see that? Sure? We can easily cancel out the two zeros. So finally we have only 12 and 6. 6 times 2, 12. 1 remaining. 6 times 1, 6 with the remaining one, 7. So the velocity is 72. Is it correct? Sorry? T is 10 seconds. Wow. T is not 60 seconds, it is 10 seconds. Then what will happen? 10 and 10 cancelled out. Only 12 will be there. If you do such a mistake in the exam, what will happen? Seconds shall get. So mistake I have written 60 in the place of 10. Who got 12 meter per second as the final velocity? Right, very good. And now read the second question and try to do it. Second question of the paper. A rocket starts to move. A rocket starts to move up with an initial velocity of 6 meters per second. It moves up with a constant acceleration and reaches to a velocity of 48 meters per second within 60 seconds. So what is the initial velocity of the rocket there? A rocket starts to move up. I wrote it here. A rocket starts to move up with a velocity of 6 meters per second. It travels up with a constant acceleration and velocity increases up to 48 meters per second. The displacement is not given, but the time taken for the motion is given as 60 seconds. And acceleration, the upward acceleration not given either. For the second question, draw the figure, mark the given data. Start. Draw this figure. The question asks us to find the acceleration and the displacement. The rocket moves up with a constant acceleration. You want to find what the acceleration is, and you should find the displacement of the rocket also. It is traveling along a vertical straight line path. The rocket travels along a vertical straight line path. The rocket travels along a vertical straight line path. Draw the figure, find the acceleration and the displacement. Do it. If you have obtained the answers, please tell me here. So, what is the acceleration? Acceleration is said to be 0.7. Very good. Displacement. Displacement is said to be 1620. Who agrees with her? Okay, try. We know initial velocity, we know final velocity, we know the time taken. Therefore, what is the best equation to find acceleration? V equals u plus a. The best equation is V equals u plus a. Look at board, stop writing. Please stop writing for a while. Please stop, look at board. Final velocity 48, initial velocity 6. Acceleration, that's what we want to find. Time is 60. Plus 6 comes to this side as minus 6. This is A into 60. 48 minus 6 is 42. This is A times 60. Just take 60 to the other side, so we can subject A. 42 divided by look at board, stop writing. Multiplication 60 comes to the other side as division 60. So 42 divided by 60 equals A. Normally we write A equals something. 42 and 60 can be divided by 6. 42 divided by 6 is 7. Am I right? 6 times 6, 36. 6 times 7, 42. 60 divided by 6 is 10. 7 divided by 10 means 0.7 meter per square seconds. Who got this answer? That's it. Now try to find displacement. Do it. Right. What is the best equation that can be used to find displacement? There are two. Normally I would like to use S equal ut plus half a square equation. You can use the other equations also, but I use this one. S is the thing that we want to find. Initial velocity 6, time is 60, plus half. Acceleration we have found it as 0.7, time is 60 square. Am I right? Just look at board. I would like to show you a different way of simplification, a different method of simplification. I do not multiply, I just write 60 to 60. I am not going to multiply it. Plus half, I write 0.7 as 7 over 10. Are you all okay with it? And square of 60, I would like to write it as 60 into 60. How do I write square of 60 here? 60 into 60. The one of the advantages, we can cancel out this 0 and this 0. Can you see that point? Then still I do not multiply. I keep this as 6. I keep this as 60 plus I don't do anything to this 60. I'll keep that 7 and 60 as they are. But this 6 I divide it by 2. Can you understand that much here? I divide the second 6 number by 2. Then what will happen? 6 divided by 2 is 3. After that, I'll take 60 out from a bracket. I take number 60 out from a bracket. The remaining number here is 6. What is the remaining number here? 7 times 3. Remaining number 7 times 3. Are you all located? Then I'll write the rest. I'll write here. Then 60 into bracket means multiplication. What is 7 times 3 here? 21. 21 plus 6? 27. You can easily, sometimes the other ways may be much easier, but I just wanted to show you how to use brackets, how to take numbers out, how to do simplifications. Because for the bio people, I am the only person who can learn maths. Am I right? Some mathematical simplifications are there. Maths people, they can learn maths from their combined maths teacher. But mathematical simplification for the bio student, they can only learn from physics subject. Okay, dear? Right. So now it's so easy to simplify. Just put 0 here. 6 times 7, 42, 4 remaining. 6 times 2, 12 with the remaining 4, 16, 1620. Okay, if you have simplified by using other methods, it's okay, but I just wanted to show you another method. Write it here. Write them all. Now read the third question and try for it. And who does not have this paper? I don't care. You can take photos of this paper, or if you send me a WhatsApp message, I can send you the recording of last week's lesson as well as the PDF of this. I should give you, there are many tunes, many papers I'll definitely give you, right? But now let's just try to manage. Question number 3. I'll read. Please don't write the question, just listen to me. A toy car, you have seen toy cars, I think. A toy car starts to move at rest along a straight path. It moves with a constant acceleration of 1/5 meter per square seconds for 40 seconds. Then it starts to decelerate and comes to rest within 24 seconds. Initially 40 seconds, at the end 24 seconds. So how do we draw this, draw a figure to illustrate the story? Question number 3. A toy car, look at board. A toy car starts to move at rest. It means initial velocity 0 meter per second. It accelerates for a period of 40 seconds. Then it may have a certain velocity v. After that it decelerates and comes to rest. It decelerates for a period of how many seconds there? 40 seconds. It decelerates for a period of 40 seconds. And then again it comes to rest. Look at body. Stop writing. I will give you the time for you to draw the figure and write down all the things. We can identify two separate sections of the motion. A to B, it accelerates. B to C, it decelerates. Okay, dear? If I mark its acceleration, A to B acceleration as A1, A1 is given. A1 is given as 1/5. B to C, if I mark it's also an as acceleration, A2 is not given. B2 acceleration, B to C acceleration, A2 not given. Time from A to B given as 40 seconds. Time from B to C given as 24 seconds. A to B displacement not given, B to C displacement not given. Right. My question is this, dear. Before you answer all the things, just listen to me carefully. Look at what. A to B velocity increases. For example, velocity increases as 0, 1, 2, 3, 4, 5, 6 like that. Let's say velocity at B is 6. Then what will happen to the velocity? It reduces 6, 5, 4, 3, 2, 1 and so on. 0. Okay. A to B velocity increases as 1, 2, 3, 4, 5, 6. B to C velocity decreases as 6, 5, 4, 3, 2, 1, 0. Therefore, what is the maximum velocity? According to the numbers that I have given. 6. Maximum velocity is 6, as I have said. At which point the object has the maximum velocity? A to B velocity increases 1, 2, 3, 4, 5, 6. B to C velocity decreases 6, 5, 4, 3, 2, 1, 0. So at which point the object has the maximum velocity? At the point B. Am I right here? A to B velocity increases. After that velocity decreases. Therefore at the point B velocity is maximum. Who would like if I explain it again? Anybody in the class who would like if I explain it again? Right. Draw this figure and mark the velocity at the point B as V max. The first thing is the part 1 of the question asks you to find the maximum velocity. After that is 1, after that is 2 and the deceleration. B to C deceleration. Try to find all of them yourself there. Draw the figure. Right, here also you should indicate the section that you apply equations. Whenever you apply an equation, you want to indicate whether you apply the equation from A to B or B to C. It's a must. It's a must to indicate the section to which the equation is applied. Please wait for a while. 1 minute. Please wait 1 minute. I'll give you time. Stop writing for 1 minute and look at board. Stop for 1 minute and look at board. A to B section. So I have indicated the section. Then I'll indicate the direction. Initial velocity is known, time is known, acceleration is known. So we can easily find the final velocity. For the AB section, let me apply V equals U plus AT. When AB section is considered, initial velocity 0, final velocity is the velocity at B, that is V maximum. Acceleration is 1 over 5, time taken is 40. Please don't write, just look at board. Therefore, maximum velocity is 40 divided by 5 is 8. Okay dear? So the maximum velocity of the object is Vmax is 8 meter per second. Who got this answer? Right. 1 more minute. Please wait 1 more minute. After that, A to B, please don't write anything, just look at board. We can apply the equation is equal ut plus half at square. In AB section, displacement is S1. In AB section, initial velocity 0, time is 40. Plus half. In AB section, acceleration is 1 over 5. In AB section, time is 40 and square of that. So S1 equals 0 into anything? 0. 1 into 1 is 1. 2 into 5 is 10. What is square of 40 here? Square of 40 is 1600. When you get the square of this, it will be double. 4 square 16. Yes. So 0, 0 cancelled out. Then you get S1 equals 160 meter. Who got this answer also? Now try to find A2 and S2. Do it. Try to find A2 and S2. Right. In BC section, look at board here. In BC section, we know the time. We know the initial velocity for BC section. In BC section, what is the initial velocity? In BC section, initial velocity means 8. Why it is 8? Velocity at the point B is the initial velocity for BC section. Am I right? Velocity at the point B is the initial velocity for BC section. Velocity at B is Vmax. Vmax is 8. Therefore, the initial velocity for BC section is 8. Is it clear for all? Would like if I explain it again? Right. So, look at board. Then, B to C, look at board carefully. Into this direction, let me apply the equation B equals U plus T. In BC section, stop writing. In BC section, final velocity 0. In BC section, initial velocity is V max. Acceleration of BC section A2, time is T2. Now look at what 0 equal Vmax is 8 plus A2. T2 is given as 24 in the equation. T2 is given as 24. Stop writing. Plus 8 can be taken to the other side as minus 8. This is A2 into 24. Am I right? Minus 8 equals A2 multiplication 24. Look at both. Multiplication 24 to 8 can be taken to the other side as division 24. Multiplication becomes division when you take it to the other side. Therefore, A2 equals minus 8 divided by 8 is 1. 24 divided by 8 is 3. Therefore, acceleration from B to C is minus 1 over 3. If an acceleration has a minus sign, what does it mean here? It's a deceleration. So no need to write again it's a deceleration. Just leave the answer with the minus sign. Examiners know physics, so they know this is a deceleration. Okay dear? And who got this answer? Complete. Okay. Right. Who wants more time to write these things? Okay. Take your time and write. It's okay, no problem. We should not be in a hurry at the beginning. Slowly but steadily we should learn. Slow and steady. But not very slow, right? Right? Please write a small note. Look at both. Please write note. Everybody please write note. A2 is the acceleration of the object from B to C. A2 is the acceleration of the object from B to C. A2 is the acceleration of the object from B to C. Full stop. The sign of A2 is minus. The sign of A2 is minus. The sign of A2 is minus. Therefore, the object has a deceleration. Therefore, the object has a deceleration from B to C. Therefore, the object has a deceleration from B to C. Okay, dear? Read that note once again. Read it for yourself. Then how do we find S2? We want to find S2. Look at both the S2 is the displacement from B to C. To find S2, B to C section, let me apply the equation S equal ut plus half at square. Please don't write, just look at both. B to C displacement is S2. B to C in BC section initial velocity is V max. In BC section time taken is T2 plus half acceleration is A2, displacement is T2, but we should get the square. Can you do the rest of the simplification and find S2? And is there anybody who has already found S2? Wow. What is S2 then? Others, please quickly find. What is S2? Who found S2? Who some? Yes. Who says S2 is 96 meters?